I hope कि screen सबको नजर आई है. Okay, yes, good, Huda.
This meeting is being publicly streamed.
Yes, so here we go. Actually, we are going to discuss about the impacts of heat. In the last lesson, I told you about that when you provide the thermal energy to a system, there are two impacts of that thermal energy. One of them is its temperature is increased. The other one is its state is changed. So when the temperature is increased, we are talking about that all area, and that is named as specific heat capacity or thermal capacity. So beta, very simple concept about the heat absorbed. For example, this is a previous concept. You have learned about this concept in your O levels or IGCSE or in your metric, I think so. Yeah, that was in ninth metric. So yeah, कौन से वाला था ये बता? Thermal ninth में था, 10 में था? नाइन्थ में था, नाइन्थ में चैप्टर था. यस, नाइन्थ में था शायद. राइट, सो दैट इज व्हाई आई विल रिवाइज इट ऑल के 2 years बैक आप लोगों ने पढ़ा होगा. सो डेफिनेटली इसमें कुछ ना कुछ चीजें ऐसी हैं which you people want to have a revision. So here I have the thermal energy is basically Q is equals to mc delta T. Okay, this was one of the formula if you have gone through that. Then Q was basically the energy, so that the energy can be written in the form of power into T. Power into T means power of any heater into time, and that power can be written in the form of VIT. This is just some revision. That is, I'm not getting in detail of this all. So VI was basically the electric power when you were using the electric heater. Okay, then at that time we were definitely having voltages and current on that heater. So voltage and current, due to this voltage and current, the power was VI. So these were three equations which were used to find out the specific heat capacity, and that specific heat in during this all we have one belief that either the heat loss is equals to zero or it is ignored. So this was what we were doing in our previous level, but actually it is not happening in this way, right? Heat is absorbed from the surrounding or heat is lost to the surrounding. So practically, if I say that H is the rate of energy absorbed or energy lost to the surrounding, then I will be having this all set up that, for example, if I have a heater or if I have a sort of, let's say I have an electric heater, and that electric heater is basically used to provide the energy to a system, right? Let's say it's quite simple technique, to make you clear. I hope that it will be helpful for you. Let's say this is a block, and that block is a sort of block in which you have made two holes. In one hole you have placed some sort of you have placed a thermometer inside. Okay, and in one hole what you have placed this is a iron block. Okay, let's say this is an iron block, and now here you have placed a thermometer inside. Let's say this is a thermometer. Okay, this thermometer can be, okay, I'm just going to give it this symbol. This is, let's say, a thermometer. Here that is a thermometer, and let's say here is a heater, right? Here is a heater which is submerged in this block. Okay, and basically that block contains some that is a material. That is why I will just connect this heater here with the help of power supply. There will be a voltmeter which will be connected to this heater, and that voltmeter will read the value of potential difference across it. And I can connect an ammeter. That ammeter will give me a sort of reading for the current flowing through this. And here is a power supply. That power supply can be variable. Okay, I believe that it is quite easy to understand. Now here I have a assumption. Before this, we were doing, we were considering that no heat is lost to the surrounding, or heat absorbed from the surrounding is zero. That all was covered, right? Are you getting my point? This is actually the insulation. This is what? This is your insulation. So whatever the insulation you have, that insulation will be, actually this is a heater, so let me draw it. This is a thermometer. So beta, this heater and thermometer, they are placed inside. This is the heater. I have drawn this diagram for you, but I will explain it with that diagram also. Okay, now if the heat is lost to the surrounding, beta, this is very important thing, that before your this level in IGCSE, what was your assumption, that all the heat, the energy provided by the heater is absorbed by, or is equal to the energy absorbed by the substance. Is it? Were we doing in this way? Is it not? So in that case, this heater can produce power, because the power of the heater was P, and that can produce the energy P into T, and that was equal to mc delta theta. This was the energy that was equal to mc delta T. If you have the heater as Pi into T, that was equal to mc delta T. That was that sort of assumption you have made. But now the game is changed. Some of the energy, what we have learned here, that the energy provided by the heater per unit time is equals to energy absorbed by the substance per unit time plus energy lost to the surrounding per unit time. Are you getting my point? Is it? This is one uh, possibility. If the energy is taken in, sorry, if the energy is taken out to the surrounding. In some cases, energy can be taken in from the surrounding. So, beta ji, this energy per unit time is actually rate of heat supplied. You got it? Rate of energy supplied. Rate of energy supplied. That is equals to rate of energy absorbed. Rate of energy absorbed by the system, you can say, plus rate of energy lost. Rate of energy lost. Are you getting my point? So this entire situation is, energy provided by the heater per unit time, that is equals to energy absorbed by the substance per unit time, equals to, sorry, plus h. In your syllabus, this h has a specific meanings. That means the rate of energy loss, that is stated as rate of energy loss or absorbed. Okay, is this clear to everyone? So if I say that this is basically power into time divided by this t, equals to mc delta t divided by this small t plus h. So this is that equation which will guide you to calculate the specific heat capacity of this setup while you have some significant heat losses to the surrounding. Now, to avoid that, what do we do? This heat loss is eliminated mathematically. Now this H is eliminated. right? Eliminate it mathematically. That mathematical means you will repeat the procedure, okay? Repeat the procedure and perform the experiment for same temperature change. Temperature change. For this or during this, you will you can use power of some different, you can use the power of heater in a different way, divided by T equals mc delta T divided by T plus H. This will be the first reading you have taken, okay? This and this would be definitely cancelled out, right? This is the first reading you have taken. Then for the second reading you will say P2T divided by T, whatever that is. If it is T1, it is T1, it is T2, it is T2, it is cancelled out. This is your MC delta T. Mass can be changed, mass can be changed. C and delta T, theta will not be changed, so T2 plus H. So you will ensure that the rate of heat change, sorry, temperature change is same. That is why heat loss to the surrounding would be same. So this gave you two equations. I will discuss these two equations here. Here I have discussed these two equations. So is this clear to everyone? Now if you have a confusion, what did I do? I just multiplied this time here and I multiplied this time here. Yani I just considered this as a linear equation. So when I considered this, or when I converted this as a linear equation, how can I write it? That the power into T is equals to mc delta T plus H into T. You got this point? This is actually H into T is not rate of energy loss. This is the total energy loss. HT is total energy loss. So that is why if I say that here, if the heat is absorbed from the surrounding, before that I told you na, okay, when the heat is absorbed from the surrounding, there are two cases. One case is heat absorbed lost to the surrounding, one is absorbed from the surrounding. Then what equation will you use, or which equation will you use? Q is equals to mc delta T minus HT, because some of the energy is absorbed from the surrounding. Okay, so actually again I have to put a new page for you, and I will explain you that what was the main objective of this all discussion. That is, yes. So as I told you that the equation you had made, that was PT equals to MC delta T plus H into T, right? This was one equation number one, when the heat is lost to the surrounding, right? It is basically heat lost to the surrounding. Now, if you are if you have designed an experiment, and in that experiment heat is coming from the surrounding, heat is absorbed from the surrounding, then what will you do, or what will you consider, or how will you consider this all? This is the graph, this is the setup. Now the heat is actually coming into the system. So when the heat is absorbed from the surrounding, heat absorbed from the surrounding, from surrounding, then what does it mean? What is happening? Now, actually, there are two energies which are absorbed by your block, or this mass. What are those two energies? One energy is the energy absorbed from the heater, plus 1 is the energy which is absorbed from the surrounding. This is equals to the energy absorbed by the block. Are you getting my point? So energy of the heater is power into time. Energy of the surrounding is h into t, because it is lost, sorry, it is rate, and rate multiplied by time, and this is your mc delta t. So beta ji, if I say that the power into time is equals to mc delta t, this h into t would be subtracted when it will be shifted on that side. So this is that equation what I told you, or which I was discussing with you. You got it? So when it is when it is lost, there will be a positive sign here, right? When there is a gain from the surrounding, there will be a negative sign. So I am just writing both the equations together for your convenience. mc delta t plus h into t, because this is the equation for heat lost, and the above equation is for heat absorbed. Is this clear to everyone? Okay, now, as I told you, that you will repeat the procedure, and then you people will make some calculations here. Actually, those calculations mean something, right? Let's say for your, I mean, for one case number one, let's say you have a container, and beta in that container, you have a sort of, this is the container, and in that container I have placed some liquid. Okay, I will give you some values here. Some water is placed inside, and when some water is placed inside, the level of the water is basically, it can the mass will be given to you, right? This is a question in your in one of your past paper. Okay, this is actually the water filled in the container. Okay, so here we go. Okay ji, the situation is very simple. That is, your container is filled with cold water, right? And now this cold water, mass of this cold water is, let's say, 250 grams. The specific heat capacity of the water is 4200 joules per kg per Kelvin. Okay, these all informations are available to you. If you are asked about something, the rest of the information will be given to you. Now, my question is, yeah, this is basically one information. The initial temperature of the water is 23 degrees centigrade, which is actually the room temperature. You got it? Are you getting my point? Hello. Is this clear to everyone? These are the properties for your water. So these are the properties of the water. Now, in this water, I placed uh, I placed a sphere, hot sphere of some mass, right? When I placed it inside, the mass of this sphere is equals to 20 grams. Okay, its initial temperature is 100 degree centigrade, rather it is because it will not melt, so we can write more than that. Suppose its initial temperature is 200 degrees centigrade. Okay, you got my point. And the final temperature of this this setup is not given to you, right? For example, if I just give you the specific heat capacity of the iron, that is almost 420 kg per degree per centigrade, or grams per centigrade. Now, my question is, if all heat is absorbed by cold water, what will be, what is the final temperature of the water and iron together? Are you getting my point? This is 4 marks question actually. In a past paper question, it is given to you, and you are supposed to calculate this all. And there is a sort of assumption, then, and that assumption is that there is no heat lost or absorbed from the surrounding. So surrounding is basically isolated in this way. This all was isolated, right? Surrounding is just covered. Now, can I ask you this question, that how to handle this question, or how to solve this? Is there anyone who can help me out to give me any idea about? Yes, you know, in this question, actually, the main frame of the game is the heat or energy lost by your iron is equals to energy absorbed by your water. So energy lost by iron equals to energy gain by water. Is it clear to everyone? So this energy is equals to mc delta t, and this energy is also equals to mc delta t. Why? Because both have a change in temperature. Are you getting my point? None of them has change in state, so that is mc delta t. But this all is this mc delta t, this is for water and this was for iron. So that is why this is mass of iron into specific heat capacity of iron into change in temperature, okay, equals to mass of water into specific heat capacity of the water into change in temperature. Now you have all these points, but you don't have one thing. What is m1 is given to you, sorry, c1 is known to you. Change in temperature is initial temperature of the water was T1 minus T2, and here that is M of the water, C of the water, and here the final temperature is T2 minus T1. Okay, so this one, this equation, mass of the iron is, what was the mass of the iron? 200 grams, yani it is 0.2 kg iron. What was its specific heat capacity? It was 420. What was its initial temperature? Its initial temperature is 200 Kelvin centigrade plus 273 Kelvin. Remember this thing, you have to add it up. Yes, this is basically your initial temperature Okay, wait. Ah, yes. You have to either I will add it at the final level. Don't worry. I can make it simple for you. Minus T2. Now it is equals to mass of the water was 250 grams, so it is 0.25 kg. Its specific heat capacity is 4200. The final temperature of the water is unknown. Initial temperature was 23 degrees centigrade. Now, please help me out to calculate this all. Yes. What will be this all? 84 into 200 minus T2 is equals to, yes, what will be this one? 150? It a calculate. Okay. Now just rearrange this all. Okay. 150 or 1050, Huda? Huda is saying it is 105. 1050. Good. Okay, so please, I need your calculation help. Hanzala, आप भी calculation में help करो बेटा. Yes, hurry up. What about this 84 into 200? 1680. Very good. 16800 minus 84 times T2 is equals to 1050 T2 minus, yes, what will be this? 1050 into 23? 1050 into 23? कितना?
24150.
Okay, good. Now arrange these T's together. These all which are including T, just adjust them together. So when you are going to adjust them together, you will say 16800 plus 24150 equals to 1050 plus 84 into T2. Yes. So what will be your T2? T2 की वैल्यू बताइए. 36.1. Yani, this final temperature of the water is how much? 36.1. You got this point? This ball was of uh, initially, what was its temperature? How much I put its temperature? 200, na? Yes. So due to the heat capacity of the water, bigger heat capacity or larger heat capacity of the water, did you notice a small temperature rise has taken place? That is why we usually put the hot iron in the water just to cool it down. Is it clear to everyone? So your temperature 2 is 273.2 plus 36.1. Yes. Kelvin में बताइए. Yes, please.
9860.
और नहीं ना 273.2 plus 36.1 करो. Oh, it is 309.3. Shabash. 309.3. 3 Kelvin. ठीक है जी. So these are, there are some questions like this. I hope that you people will get it done. मुश्किल तो नहीं है. आपको थोड़ी थोड़ी प्रैक्टिस कराऊंगा and hopefully you people will be able to manage this all inshallah. Is it clear? Okay. So this is basically the concept of thermal capacity. Hope that it would be fine. Next time, inshallah, we will be continuing with some different concept, that if the temperature, if all energy is not added or absorbed, then what will happen? Okay. See you then, inshallah.